Now, as programmers, we need to understand that every single language fits into a particular category, and we need to know which category that language fits into. So we have three categories. You have programming languages, and then you also have scripting languages, which go hand in hand. They are for programmers to define sets of instructions and run those instructions and provide logic, and of course that logic can be run on the hardware. These are programming or scripting languages. However, there is another type which is called markup languages. Markup languages are not programming languages. Markup languages are presentational languages. For example, HTML. Well, HTML is not asking questions for the computer, it's not comparing things, it's not asking logical questions, and it's not defining a set of subroutines and so forth. It's just a very simple language, and it's defining the structure of a HTML page, the stuff that you view inside of your web browser. So it structures the data and it tells your browser how to structure that particular page. But it is not a programming language. Also, CSS is involved in that. Again, CSS is a markup language. It's purely there for presentation, and it's to tell the browser how to present the data, such as styling the page in a particular way. It is not a programming language. It is just, in fact, a markup language. But now I want to clearly define most categories of programming languages so that you can understand what is a programming language, also what is a scripting language, and why a scripting language can in fact be called a programming language, and also what are markup languages all about. So you've heard me say that programming and scripting languages go hand in hand, and that is in fact true. You can think of scripting languages in the category of programming languages. It's not incorrect to say a scripting language is in fact a programming language. But the reason why we have this subcategory inside of programming languages is because it helps us define the nature of that language. In other words, how it's compiled. So we have some programming languages and they fit into this category very well, such as C, C#, C++, and Java. But you also have other programming languages, but these programming languages fit nicely into a subcategory, and they are scripting languages, such as JavaScript, not to be confused with Java. I'd like to illustrate that Java and JavaScript are two completely different languages with different syntax. You also have PHP, HHVM, and SQL. If you don't know what those languages are, it's not a problem. But what we need to understand is, why is there a subcategory here? So let's take a look at these programming languages that fit very neatly into the programming language category, such as C, C++, C#, so forth. Well, these languages, what we do is we write out these languages on our computer in a human readable form. And then what we do is we hit the compile button on our computer, which turns it into a binary form. We can have bytecode, we can have, ones and noughts machine code. And what we can do then is we can take that machine code and distribute it to other computers. Now there's a benefit here because it protects the source code. We have the source code, but yet we give them the binary data so they can run that program on their computer. So these aren't interpreted on the client's computer. Scripting languages that, yes, end up as ones and noughts, but they are either compiled or interpreted, or a mixture of the two, on the user's computer. So the way it's executed is different. What we do is we create the script. But we don't hit compile on our computers, the programmer's computer. All we do is we distribute that script to the other computers. It's compiled or interpreted and so forth right on the hardware that we're trying to run this script on. And it makes things a lot more convenient in order to distribute our programs. And you can see how JavaScript, for example, being distributed to all these different web browsers to a ton of different people with different operating systems and hardware configurations. It's easier for us as web developers, for example, to distribute JavaScript rather than trying to pre-compile the code and then trying to send that code out. Instead, we can compile it just in time on the user's computer, avoiding all of the hassle of predefined compilation. So I want to stress that they're all programming languages because eventually they end up as binary data and executed on the hardware. However, the way in which that happens is very different. But that's the difference really between programming languages and the subset, the subcategory, if you will, of scripting languages. But it is not incorrect to call a scripting language a programming language. I could call JavaScript a programming language or a scripting language. Those are both truthy statements. But I cannot call C a scripting language. C can only be a programming language. Therefore, I cannot call it a scripting language, otherwise that would be technically incorrect. It's not. So those are the differences there, but you'll notice I didn't mention HTML and CSS, which is a large part of web development. Those are markup languages. Now these don't run routines, they don't check for things, they don't do logical operations like programming languages. Instead, these markup languages are used for presentation. How am I going to lay this data out? So what happens is the HTML and CSS goes to the web engine, and the web engine will take a look at this data that you've sent it, and then it will build a page based on what you've defined in your HTML, and also it will style it by the CSS. But please do note they are not programming languages, they are markup languages. They're in a completely different category, completely separate.